Hello friends, Mr. Burrell here. We're nearing the end of this current unit. We've been talking about graphing trigonometric functions. We've talked about graphing sine functions and cosine functions and tangent functions. And we specifically talked about graphing these different functions when we have changes in amplitude, changes in period, changes in the midline, or in other words, changes in a vertical shift. So now we're going to put it all together. We're going to put all of these different transformations that can happen with a trigonometric function's graph and put it into one. So by the end of this lesson, by the end of this video, these are the things that I hope you're able to do. You're going to be able to determine the midline, amplitude, and period from a trigonometric equation, graph the midline, amplitude, and period from a trigonometric equation, and write the equation of a trig function with the midline, amplitude, and period changes from a graph. From an equation, we're going to find all those parts and draw the graph. From a graph, we're going to find all those parts and draw the equation. Okay, so we've discussed finding midline, amplitude, and period of a trig function from its equation already. So now all we're doing is putting it all together. So when I have a trig function of this form, y equals a times the sine of b times theta plus c, or y equals a times the cosine of b times theta plus c, or y equals a times the tangent of b times theta plus c. A changes the amplitude, so this number in front changes the amplitude. B changes the period, so this number b is going to affect the period, or how often the graph repeats itself. And c changes the midline, or how much up and down it's going to move. So, let's practice this. Again, all these are things we've done already. We're just putting it all together. So for each one of these equations, I'm going to identify the midline, I'm going to identify the amplitude, and I'm going to identify the period in both degrees and radians. In both degrees and radians. So, this one is y equals 10 times the cosine of theta. So, is there a midline shift? No, there isn't a midline shift. I'm not moving up or down at all because there's nothing being added on the end here. So my midline is still at just y equals 0. It's still right at the x-axis. Is there a change in amplitude? Yes, there is. I'm multiplying in the front of my trig function, cosine of theta, by 10. So my amplitude is 10. Meaning that I'm not going to go 10 above or 10 below the midline. So this is my cosine function. It would look something like this or something like that, where it starts up here at 10 and goes no lower than negative 10. Is there a period change on this cosine function? Well, no, there's nothing being multiplied in front of theta here. So the period of this function in degrees for the cosine function is 360 degrees. And in radians, it is 2 pi radians. 360 degrees or 2 pi radians would be a full cycle for that cosine function. Let's look at the next one. Y equals sine of theta plus 4. Is there a midline shift? Yes, there is. I'm adding 4 on the end here, so my midline is now at y equals 4. So instead of the midline being at 0 here, my midline would be up 1, 2, 3, 4 spots. So my midline would be up here now. Is there an amplitude change for this function? Well, no. There's nothing being multiplied in front of the sine of theta, so the regular, the traditional, the parent amplitude for this function is going to be 1. So taking a look at my graph here, my graph's not going to get any lower than 1 below or higher than 1 above the midline. This is a sine function. It's going to look something like this. Something like this. Okay. Sine functions start at the midline, cosine functions start at the amplitude. And again, is there a period change for this function? No, there is not, because there's nothing being multiplied in front of the theta. So the amplitude is just, or the period, sorry, is just going to be the regular parent period, which for a sine function is 360 degrees, or 2 pi. Okay, let's look at this third one. Y equals 1/2 times the sine of 4 theta. Is there a midline shift? No, I'm not adding anything on the end here. There's no c value, so my midline is still going to be at 0. So y equals 0, that's my midline right here at 0. Do I have an amplitude change? Yes, I do. I'm multiplying by 1/2 in the front here, so my amplitude is now going to be 1/2. So if this was 1 above and 1 below, I'm only going to go up to 1/2 above and 1/2 below. So my sine function is going to look something like this, maybe. A little bit squished, a little bit flattered. And is there a period change? Is there a period change here? Well, yes, there is. I have a number being multiplied by theta, the number 4. So in order to find the period, I have to take the parent function's period, which would be 360 degrees, or 2 pi, and I have to divide by 4. Divide by 4, divide by 4. Well, 360 degrees divided by 4 is 90 degrees. And 2 pi divided by 4, well, 2 over 4 reduces to 1/2. So it's going to be 1/2 pi, or in other words, pi over 2. That's going to be my period in radians. So if this was my parent graph and it was in degrees, this was 360 degrees. My new period would be 90 degrees. So like 90, 180, 270. My new period would look something like this. I'd be able to fit 4 cosine cycle, or sine cycles, 4 sine repetitions between 0 and 360 degrees. Mainly one at 90, another 90, another 90, another 90. So that would be my new graph in that new period. Y equals tangent of 2 theta. Is there a midline shift? No, there is not. So I'm just going to call it y equals 0. So the midline is still at 0. Is there an amplitude change? Well, even if there was a number in front of the tangent, the amplitude doesn't change because tangent doesn't have an amplitude. It goes up and down forever and ever without ending. Is there a period change? Yes. Because there's a number being multiplied by theta, there is a period change. So I'm going to take the parent tangent function's period, which is 180 degrees, or pi radians, and divide by 2. So in degrees, my period is 90 degrees. In radians, my period is pi halves. So say this was 0, 90, 180, 270, 360. Instead of my graph repeating every 180 degrees, my tangent graph is going to repeat every 90 degrees. So I'm going to cross the x-axis here, 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 and here, with asymptotes halfway in between. So at like 45 degrees, 135 degrees, etc., etc. So my tangent function, wow, that was good. My tangent function is going to look something like this, repeating itself every 90 degrees. Okay, now let's look at the last one, putting it all together. This is y equals 3 times the cosine of 3 theta plus 2. Do I have a midline shift? Yes, I do. This is shifted up 2 spots, so my midline is now at y equals 2. So my graph here, if this is the x-axis, I'm shifting up. Let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I'm shifting up 2 spaces, so this is my new midline. Do I have an amplitude shift? Yes, my amplitude is going to be 3. That number that's multiplied in front changes the amplitude, so it's going to be 3. So I'm not going to go 3 above or 1, 2, 3 below that midline. And do I have a period shift? Yes, I have cosine of 3 times theta, 3 theta. So in order to find the period, I'm going to take the parent function's period, which is 360 degrees, or 2 pi, and divide that by 3. So 360 divided by 3 is going to be 120 degrees, so that's my new period, or 2 pi thirds. So if I go, let's see, every 120 degrees, so here's like 30, 60, 90, 120, 150, 180, 210, 240. something like that. This graph, since it's cosine, it starts at the amplitude. It's going to come down and repeat itself every 120 degrees. Something like that. It's going to repeat itself every 120 degrees with an amplitude of 3 and a midline at y equals 2. Okay. Let's practice a couple other graphing ones. So this one says find the amplitude and the period of each function. So I'm going to find the amplitude and the period of each of these functions, and then I'm going to graph it. Let me move my face here. Oops. I'm going to find the amplitude and the period of each of these functions, and then graph it. So this one says y equals 1/2 times sine of theta over 3. Or in other words, 1/2 times sine of 1/3 theta. Okay, there's not a midline shift, so that's why I didn't write it here. There's no vertical shift because there's nothing being added on the end here. Do I have a change in amplitude? Yes, my new amplitude is 1/2. So above this midline, I'm not going to get any higher, wow, that was good, any higher than 1/2 above the midline or any lower than 1/2 below the midline. It would be a pretty squished graph. What's my period? Well, this is sine of 1/3 theta, so in order to find the period, this is in degrees, I'd have to take 360 degrees divided by 1/3. Well, I don't like dividing by fractions, so what am I going to do? I'm going to copy dot flip, or keep change flip. So I'm going to keep 360 degrees, change this to times, and flip this fraction upside down. So 360 times 3, I believe, is 1080. Do I trust my math that much? Yes, I do. 1080 degrees. So in degrees, my period is 1080 degrees. If I was finding the period in radians, I would take 2 pi times 3 over 1, which would give me 6 pi radians. Okay, so let's draw this. This is a sine function, so it's going to start at the midline. I'm going to make a full revolution, full repetition, full wave by the time I get to 1080 degrees, and the amplitude is 1/2. So I'm going to go up, down, up. Something like that. I'm not a perfect artist, but it's going to look something like that, making a full repetition by the time I get to 1080 degrees. And I could keep going on and on and on and on and on if I wanted to. Okay, let's look at this one. Y equals 1/2 times the sine of 4 theta. Well, there's not a vertical shift again because I'm not adding anything on the end here. So what's my amplitude? My amplitude is 1/2. What's my period? I'm looking in degrees here, so my period is going to be 360 degrees, or 2 pi, divided by this number, divided by 4, divided by 4. So my period, 360 degrees divided by 4, is 90 degrees. If I was finding it in radians, 2 pi over 4 would reduce to 1/2 pi, or 1 pi over 2. So let's graph it. My midline hasn't changed. My amplitude, I'm not going any higher than 1 above the x-axis or 1 below the x-axis. My period is 90 degrees. So here's 60, 120, here's 90 degrees, another 90, another 90. That's how often I'm going to repeat my graph. So this is a sine function. I start at the midline. I'm going to go up, down, up, down, up, down, etc., etc., something like this. That would be my graph of y equals 1/2 times the sine of 4 theta. The period's kind of been squished together, and it's been squished down because of that small amplitude. And notice again, I can fit 1, 2, 3, 4 repetitions by the time I get to 360 degrees, which makes sense with this number 4 here. Okay. Now, last part, we're going to find an equation that fits each of these graphs. So on each of these graphs, I need to determine if there's any vertical shift, if there's any change in amplitude, and what the period is. Same over here, I need to find if there's any vertical shift, any amplitude, and any period shift. Okay? So, on here, it looks like I don't get any higher than 1, any lower than -1, which means my midline is still at 0. So there is no vertical shift. And since I'm going one above or one below, it doesn't look like I have any amplitude change either, so my amplitude is 1. Well, what's my period? How many degrees does it take to go through one full revolution? Let's see. So I go up, down, back up again to the starting position. It looks like it takes 180 degrees to get through one full repetition, which means I could get 2 full repetitions in the span of 360 degrees. Okay. Second question, is this a sine or cosine function? Well, it starts at the midline, so this is going to be a sine function. Y equals sine of something theta. There's no amplitude change. There's no vertical shift. There's only going to be a period change. Well, in order to find this b value, I have to take the parent function's period divided by this graph's period, which is 180. 360 divided by 180 is 2. So the equation for this graph is y equals sine of 2 theta, which that 2 makes sense because it does indeed take 2 full repetitions to get to 360 degrees. Let's look at this number 30 here. So first of all, I don't go any higher than 1. I don't go any lower than -1, which means my midline is at 0, which means there's no vertical shift. My vertical shift is 0. It doesn't move up or down. And my amplitude is still 1 because it's still just 1 above or 1 below there. So what's the period? So I start at the top. I go down. I go up again to 4 pi. So my period is 4 pi. We're talking in radians here. Well, next question, is this a sine or a cosine function? Well, I start at the top of my amplitude, so this is going to be a cosine function. There's no vertical shift, or there's no amplitude, sorry, and there's no vertical shift. All I'm going to have is a change in period, so I need to determine what's being multiplied by theta here. Well, in order to determine what this b value is, I'm going to take the parent function's period, which is 2 pi. 2 pi radians is the regular period for a cosine function, and divide by this graph's period, which is 4 pi. Well, 2 pi divided by 4 pi, those cancel out. 2 divided by 4 reduces to 1/2. 1/2 theta. So my function, my equation is y equals cosine of 1/2 theta. And that 1/2 kind of makes sense because by the time I get to 2 pi revolutions, I've only gotten, or 2 pi radians, I've only gone through 1/2 of a cosine wave. 1/2 of a revolution. Okay, I want to do one of the homework problems real quick. This homework problem is number 28 on your homework assignment. And it says y equals 3 times the sine of 4 theta. And I want you to graph it in radians, sorry. So I'm going to determine, is there any vertical shift, is there any amplitude change, and is there any period change? Well, there's nothing being added on here on the end, so there's no vertical shift, which means my midline is still going to be at 0. Is there an amplitude change? Yes, my amplitude is going to be 3. Is there a period change? Yes, my amplitude, I'm going to take the parent function for sine, that period, which is 360, in radians, 2 pi radians, divided by 4, divided by this b value. Remember that the period is equal to 2 pi, or 360, over b. So 2 pi divided by 4, or 2 pi divided by 4, 2 pi divided by this b value. 2 over 4 reduces to 1/2. So 1/2 pi, or pi over 2, is my new period. So, on here, my amplitude is 3. I'm not going to get any higher than +3 or any lower than -3. 3 above or 3 below the midline. And then my period is pi halves. So I'm going to repeat myself every pi halves. I'm going to repeat my graph every pi halves radians. And this is a sine function, so I start at the midline. So I'm going to go up, down, up, up, down, up, up, down, up. See how like tall and skinny this is? Up, down, up. So I've gone through 1, 2, 3, 4 repetitions before I get to 2 pi, which makes sense because that number there is 4. So that would be my graph. Okay, I think that's where we're going to call it. That's all I've got for you. Hopefully now you feel a little bit better about determining midline, amplitude, and period from a trig equation, graphing those from a trig equation, and from a graph of those where some changes have been made. Hopefully you can write the equation of that trig function with the midline, amplitude, and period changes. That's all I have for you. I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever, and I hope that you enjoyed that as much as I did.